In this video, we will discuss uniform circular motion. Uniform circular motion is essentially motion of an object in a circular trajectory with constant speed, as shown in this diagram. However, as the direction of the object changes as it moves in a circle, its velocity will change, so it has a varying velocity, which in turn implies acceleration. Let us talk about the changing velocity more carefully. This diagram shows an object moving around a circular trajectory in a counterclockwise manner with velocity v, and the magnitude of the velocity, which is the speed, is a constant. When the object is at point 1, the direction of the velocity is as follows. So it's pointing upward, and we can write the velocity vector, say as magnitude v, pointing in a j hat direction in the unit of meter per second. Now what happens when the object is at point 2 here? At point 2, the velocity will be heading as shown. So this arrow is pointing leftward. So the vector v will now look like this, minus vi hat, of course in the unit of meter per second as well. Next, point number 3. When the object reaches point number 3, its velocity will be in the direction of minus j hat. So the velocity vector is written as minus v j hat. Next, point number 4. At point number 4, obviously the velocity will be heading like that, with the velocity vector now taking the following form, vi hat meter per second. So since velocity is changing, the rate of change of that velocity, which is acceleration, must be non-zero. So the question is, what is this acceleration in terms of magnitude and direction? This acceleration has a term. We call it the centripetal acceleration. And its magnitude is given by v squared over the radius of that circular trajectory. Now this v is that constant speed. The direction of this centripetal acceleration is towards the center along the radial direction. So for an object that is here, the direction of the centripetal acceleration will head from the object to the origin. Likewise, after the object has moved to this coordinate, to that location, its centripetal acceleration will be in the following direction, given by this arrow, and after the object has moved all the way to this position, the acceleration will be heading in that direction, and so on and so forth. Because of the radial nature of this acceleration, one can write the centripetal acceleration in the following way. So we are using the term radial as a subscript to a to signify that the direction of the acceleration is directed radially. Next, we want to explain why the direction of the centripetal acceleration is radially inward, that is, from the object towards the center. Suppose we have an object moving in a uniform circular motion in a counterclockwise direction with a uniform speed of v. Now let's concentrate on 2 points, point 1 and point 2. The velocity of the object at point 1 will be heading in this direction, shown by this green arrow. Let's call it v1, vector v1. By the time the object gets to point 2, its velocity there will be vertically downward, shown by this blue arrow, and let's denote it with v2. So 2 is the final point, 1 is the initial point. You can look at it that way. Now let's compute the difference between v2 and v1. The change in velocity of the object as it goes from 1 to 2 is given by v2 minus v1. Since a v2 minus v1 can be looked at as v2 plus minus v1, delta v is given by that black arrow. So the change in velocity of the object as it moves from 1 to 2 is given by that. And since the direction of the acceleration is parallel to this change in velocity of this object, it follows that the acceleration must also point along that direction, namely like this, which is in a radial direction, and pointing towards the center. Another thing worth mentioning about the speed is that the expression for the speed. The expression for the speed can be written in terms of the radius of that trajectory as 2 pi r over t. So this r here is the radius of that circle, and this time here is the time it takes for the object to go one complete cycle. So basically what this equation is saying is that the constant speed equals the circumference of the circle, which is the distance the object travels when it goes through one complete cycle, over the time it takes to go through the complete cycle. Let's look at the simple example here. Calculate the centripetal acceleration of a cyclist with a speed of 20 meters per second when rounding a turn of radius 50 meters. So basically what this problem is about is that you have a cyclist doing this turn at a speed of 20 meters per second, and the radius of that turn is 50 meters. So to a good approximation, this turn can be taken to be as part of a circle. So what is the acceleration? So the centripetal acceleration is, the formula goes like A radial equals the speed squared, speed is 20, so square of that, divide by r, which is the radius of that circle, which will give you 8 meters per second squared. Now what about the direction of this acceleration? Well, if the cyclist is here at that time, then the direction of the acceleration is from the cyclist to the center, like that. So that is the direction of that centripetal acceleration. Example 2. Passengers in a carnival ride travel in a circle of radius 6 meters. They complete one circle in 5 seconds. What is the centripetal acceleration? So let's assume this is the circle. The radius is 6 meters. Let's say they move like that, and the period, the time it takes to go one complete circle, that is known to be 5 seconds. Now, since the centripetal acceleration equation is given by the square of that speed over the radius, now we know what this radius is, it's given 6, but we don't know what v is, but we can compute that. Now v, if you remember, it's given by the circumference of that circle divided by the period, the time it takes to complete one complete circle. So since the radius is known, radius is 6, time is 5, so this is the constant speed. Substituting the speed into this equation will give you the centripetal acceleration. Since the speed comes out to 7.54 meters per second, substituting 7.54 in here gives you 7.54 squared over 6 meter per second squared, which is 9.48 meter per second squared for the centripetal acceleration. Please share, like, and subscribe if you find the content useful. Thank you for watching.